In this lecture, we will talk about filtering long data sequence using overlap step method. First, we will consider overlap step method algorithms. Then we will discuss about one example which we already considered in case of OLS. First, the input long data is basically divided into small sections. Each section length is capital L. Then each individual frame output is basically computed, and the process is basically number one step. The same as we did in case of OLS, we have to append zeros at the end of this h of n. How many number of zeros? Capital N minus capital M, so that it becomes to be capital N lengths. Now second step, we have to prepend. Prepend means we have to append, we have to add numbers to the left hand side. So how what are the numbers? It's basically the numbers which has been which will be taken from the previous frame last n minus L number of samples from the previous frame. If you consider this is going to be the frame number xi, so L minus n number of samples last n minus m number of samples from xi minus 1 frame. Okay, so if it is going to be the first frame, so L minus n minus L number of zeros should have to append at the end, because there was nothing before starting the first frame. So rest of the process is very simple, as we did in case of OLS. We have to find out the each frame output, and then during combiner block we have to discard from each frame, from each of the output frame we have to discard first n minus L number of samples to form the final output. And what would be the length of final output? The same thing, that is the length of x of n, original length of x of n plus m minus 1. Now let's see what is the concept of prepending operation in case of OLS. Let's say that we had same sequence x of n, that is a 12 length sequence, and these are basically we considered capital L equals to 4. So we have divided the complete data into three different smaller parts, small frame parts, x1, x2, x3. So each frame contains 4 number of samples. Each frame contains 4 number of samples. So what would be the prepending operation? That means we are basically focusing on step number 2 in this particular frame output computation block, frame number 2. So what is the value? N minus L, that is 6 minus 2, that is 6 minus 4, that is equals to 2. So prepending number of samples, how many number of samples we have to prepend? 2 number of samples. Okay, so this is basically the first frame. So if we prepend the samples, 2 samples at the left hand side, what would be the samples? Because the actual signal starting from here, so there was nothing previous of that, so we have to prepend 2 zeros. So now it takes 6 length sequence. Okay, now if we while we are considering second frame x2, that means 1, 2, 3, 4, these 4 samples are taken as it is, and we have to prepend the samples from the previous frame last 2 sample points. So previous frame is basically x1, its last 2 sample points of -1 and 3, so these are taken as a prepending samples. So now this is basically the 6 sample point second frame. Similarly we will do 6 sample point third frame. Is it finished? No, it is not finished, because if there was some sample points that would take these 2 sample points as a prepending sample points, there is nothing means we can consider these are basically filled by zeros. So there are 4 zeros. Now for that particular 4 zeros, these 2 sample point will work as a prepending samples, so we have to consider this frame as well. Okay, so x4, the last frame, is basically contains all the zeros, but because the prepending samples are coming from here, these 2 sample points -1 and 1, we have to consider this frame also for computation, otherwise you won't match the output length. Mind it, this is very crucial one. Okay, so how many number of frames you have to compute here? 4 number of frames. So we will check, we will verify in numerical computation whether it basically matches the output length exactly same as it is expected from linear convolution. Let's talk about the same problem. H of n is basically 1 minus 1 1, and x of n is basically these 12 sample points. We have taken 3 different parts. Each part contains 4 number of samples, and each output length will be of 6, because we know what is the rule. So first frame we are considering, that is being taken x1 as a first frame and depending by zeros, and if we just do computation we will find out this as a y1. So let's say that why we are basically how we are placing the output sequence. The output sequence is basically placed such a way that it is a right justified way, that means a right side aligned, that is last sample point of the first frame is basically aligned to the last sample point of the first frame output. So in case of OLA, that was basically left side aligned, that is first sample point of the first frame is basically aligned to the, it was basically aligned to the first sample point of the first frame output, but here it is right side aligned. These two sample points are coming due to these these two sample points are basically allied to these two prepending sample points. Similarly, this is basically the second frame output 6 sample points, and these two sample points basically allied to these particular last two sample points of the previous frame, and these are basically allied to this original sequence. So similarly, x3 we can compute this way, and the last frame we took, that was all 4 zeros and these two samples, so this is the computation of last frame output. So as a whole, these are all 4 frames. Now we have to go for a combiner process. What is a combiner process? We already have seen that from each frame, each output frame, n minus l number of first n minus l number of samples should be discarded. We have to simply throw it out. So n minus l means n minus l means 2. So from each output frame we have to discard first 2 samples. So these black shaded numbers or cells are we are basically discarding from each of the output frames. So if we do that, the final output, it takes 1 2 minus 2 6, 1 2 minus 2 6, then minus 6 9 minus 5 0, then 5 minus 3 minus 1 3, then minus 2 1, and these two are automatically 0. So there is no contribution above of these 2 samples to the final output, because you know that in case of final frame computation, if we just go back here, so how many number of samples were there? Original samples were these 2 samples, these are 0, these are not contributing anything, these 2 sample points, and length of h equals to 3, that is 3 plus 2 5, so 5 minus 1, that is 4 number of samples. So that's why 4 number of valid samples, out of which we have to discard these 2. So these last 2 sample point, these 2 sample point will contribute to the final output. And if we just go and check the number of samples in the final output, this is equal to length of x, that is 12 plus 3, 15 minus 1 14, and the sequence exactly the same what we basically achieved in case of OLA. And now you can just verify it just by applying linear convolution of this particular 2 sequence. You will get the exactly same sequence of it. Okay, so that's it. The next topic we will discuss about first Fourier transform algorithm.